Functional Safety Solutions. Overview. In recent years, demand for machine safety, which emphasizes safety through technology and design, has been increasing. In this series, we'll use the AC Servo CC-Link IETSN Safety Demonstration Unit to explore Mitsubishi Electric's functional safety solutions. The AC Servo CC-Link IETSN Safety Demonstration Unit includes these 6 safety features. This video introduces each of these safety features. Use the indicated timestamps to jump to a specific feature. The STO function stops the motor by turning off the motor current. Turning off the power supply to the motor prevents a stopped motor from starting unintentionally. This function also reduces costs by eliminating the need for an electromagnetic contactor. Used primarily in presses, STO makes it safe to perform operations such as changing dies. Let's see the safety demonstration unit in action with an actual application example. These are the main components of the demonstration unit used in this example. This configuration is set up for operation of a press and conveyor belt. During automatic press operation, both the press and conveyor belt are operated continuously. If a hand is inserted while the press is descending, the sensor is activated and the STO function turns off the power supply to the motor, stopping the operation of the press. With the STO function, only the power to the motor is turned off without cutting off the servo amplifier control circuit power. In addition to ensuring the safety of both operators and equipment, the STO function reduces both the restart and recovery times, as origin return is not necessary. This function can also help reduce costs by eliminating the need for an electromagnetic contactor. The SS2 function decelerates and stops the motor while monitoring the time and deceleration. The function then keeps the motor in a stopped state while maintaining the power supply. This function is similar to the SS1 function, but with SS1, the power supply is turned off, STO, after the motor stops. In addition, while SS1 requires a mechanical mechanism for holding the position, SS2 maintains the motor position using a servo system. With conventional systems, power to all processes had to be turned off for maintenance, resulting in long restart times. With the SS2 function, downtime can be reduced while also ensuring safety. Let's see the safety demonstration unit in action with an actual application example. During automatic press operation, both the press and conveyor belt are operated continuously. If a hand is inserted while the press is ascending, SS2 activates and brings the system to a controlled deceleration stop. Using the SS2 function makes it possible to keep the machine in a stop state without cutting off the drive energy, helping to reduce downtime and significantly improve uptime. The SLS function monitors the motor shaft speed to ensure that it does not exceed the speed limit. Without the SLS function, if an error occurs, the motor shaft speed could suddenly accelerate, causing the workpieces to be ejected. The SLS function ensures the machine is safely stopped if the motor shaft reaches the speed limit. The function can also maintain low speeds, making it safe to perform adjustment during maintenance without having to stop the machine unnecessarily. In actual on-site operations, the function is generally used for setup changes. Let's see the safety demonstration unit in action with an actual application example. During conveyor belt speed monitoring demo operation, the conveyor belt is operated continuously. Pressing the speed error button will cause the conveyor speed to gradually increase. When the speed reaches the monitoring speed limit, 180 mm per second, the STO function will activate, bringing the machine to a stop. The SLS function makes it possible to set the monitoring speed to ensure safety when working near the machine during maintenance, eliminating the need to stop the machine unnecessarily, reducing downtime, and maintaining productivity. The SDI function monitors the rotation direction of the motor shaft. This makes it possible to confirm the motor shaft is rotating in the specified direction, ensuring safety by preventing unexpected movements that could lead to contact accidents. The SDI function is most commonly used to prevent entanglement and other issues in roll press machines. Let's see the safety demonstration unit in action with an actual application example. With manual press operation, the operation of the press machine must be started manually. When monitoring the press direction with the SDI function, if a hand is inserted while the press is descending, the STO function stops the machine. Conversely, if a hand is inserted while the press is ascending, the STO function will not activate. The SDI function makes it possible to monitor the motor shaft direction to confirm rotation is in the specified direction, thereby preventing unexpected movements and ensuring safe operation by avoiding risks like a hand becoming pinched during pressing. The SLI function monitors the motor shaft movement to ensure that it does not exceed the specified limit. Without the SLI function, if an error occurs, the motor shaft movement could become larger than expected, leading to the risk of hands becoming entangled. The SLI function ensures safe operation by stopping the machine if the motor shaft movement reaches the specified limit. In actual on-site operations, this function is generally used when performing maintenance operations such as fine-tuning operations. Let's see the safety demonstration unit in action with an actual application example. After starting press travel monitoring demo operation, press operation can be started manually. In this example, the SLI limit is set to 50 millimeters. With press operation at 30 millimeters of movement, the STO function will not be activated, as the specified limit has not been exceeded. However, at 55 millimeters of movement, the STO function is activated once the movement reaches the specified limit of 50 millimeters, and operation will be stopped. The SLI function makes it possible to set specific limits to ensure worker safety when approaching the machine during maintenance. Limiting the travel amount also prevents contact accidents caused by operational errors. The SLT function monitors the motor torque to ensure that it does not exceed the specified limit. Without the SLT function, there is a risk of severe injury if a hand becomes caught in the machine. The SLT function ensures safety by stopping the machine if the torque reaches the specified limit. Let's see the safety demonstration unit in action with an actual application example. After starting press torque monitoring demo operation, press operation can be started manually. In this example, the torque limit is set at 50%. During operation, the torque value is monitored, and the STO function activates to stop the machine if the torque reaches the specified limit. The SLT function allows users to set a torque limit to prevent excessive torque during operation, ensuring operator safety and preventing accidental damage to workpieces. Learn more about functional safety solutions and how to prevent accidents to create systems with functional safety.